Hi guys. Okay, this is going to be used for differentiation. We just finished studying how to solve linear equations of all different kinds. One step, two step, multiple step with variables on both sides, and then rewriting literal equations. The very next section in our book is actually inequalities. Now, the cool thing is, if you can solve an equation, you can solve an inequality. The only difference is the solution notation and the number of solutions that you have. We will talk about that in this video. Now, you are not taking notes, you are just watching. This is going to be used, as I said, for differentiation. After you watch this video, you'll do a quick assessment on Canvas, and those who pass with an 80% or more can move on to an extension type of activity because it shows that you've already studied these. Now, this is not new. You've actually studied these in your 8th grade math class. So hopefully this is not new to you. We're going to go ahead and start. So just watch. When you're solving inequalities with any operation, it's almost exactly the same as solving equations with one simple rule that we'll cover on the next page. So let's look at this very first equation. I'm going to go ahead and let's see, here we go. We're going to call this equation A. If I want to solve this, I would pretend that there's an equal sign here in this place where the inequality is. There's not, it's a less than symbol, but we're going to pretend it's an equal sign. And we're going to get rid of the 11 by using inverse operations, exactly the same way we would with an equation. Now, I'm going to go ahead and add. These cancel. We get k is less than negative 14. Now, talking about solutions, we just finished equations, like I said. And if this, let me go ahead and use the magic pen, because I like the magic pen. If this were an equal sign, we would have one solution. And this would be, let's say, negative 12, negative 13, negative 14. It would be right here, one solution. All right, but this is actually an inequality, which means there's more than one solution. So I'm going to redraw this number line, negative 12, negative 13, negative 14, and we are going to put an open circle here at the negative 14. And what this inequality says is anything that is less than negative 14 is going to be a solution to this inequality. And we can actually check that. So let's check negative 15. Is negative 15, if I plugged it in, less than negative 14? Yes, it is. How about negative 20? If I plugged that in, is that less than negative 14? Yes, it is. What if I chose something like this, negative 12, and I checked it? Is negative 12 less than negative 14? No, it is not. So what this means is that our solution set is infinite solutions that are less than negative 14. All right, so instead of one solution, we have infinite. Let's go to our next one, letter B. Again, let's pretend that there's an equal sign there. I'm going to use the magic pen because it disappears, and let's pretend just temporarily that there's an equal sign there. Okay, there's not, but if there was, we would add 9 to both sides, just like an equation. I'm going to add, these cancel. B is, let's see, B is less than or equal to a positive 8. I'm going to use a number line. And if this were, let's say, 6, 7, 8, 9, what I'm going to do is this is saying that B is anything that is less than or equal to 8. So instead of a open circle, I'm going to close the circle now. And that is because we have less than or equal to, so the circle is closed. And we're going to graph everything that is that way. Anything less than or equal to 8. If we wanted to check it, let's go ahead and check 6 is, let's write it this way, 8 greater than or equal to 6. Is that true? Yes, it is. How about if we checked 7? So 8 greater than or equal to 7, is that true? Yes, it is. What about 9? 8 greater than or equal to 9? No, it is not. So what that says is our solution set is everything that is less than or equal to 8. All right, let's go on to the next problem. So what we did, by the way, is we just demonstrated solving inequalities using addition and subtraction. This was addition, this was subtraction. So obviously, if we're doing all 4 operations, we're also going to solve something that is multiplication or something that is division. Let's move on to this next one. We'll call it letter C. Just as if this were an equal sign, I'm going to use magic pen. If this were an equal sign, what we would do is we would divide by 4 on both sides. All right, and that would allow us to get rid of this right here. This cancels, becomes a 1. So x is less than 2. Now the solution set here, here's your number line. If we had 0, 1, 2, 3, it's going to be an open circle at 2, and we want everything that is less than 2. Notice it's an open circle because we only have a less than. We do not have a less than or an equal. That means open circle, and that is not new. Like I said, that's something that hopefully you have seen before. Let's look at our very last example. This on this page, this is going to be example D. And again, we're going to pretend exactly as if it were an equation. Pretend this is an equal sign, and we're going to treat it like an equal sign. To get rid of this division, this is dividing by 2, we do the inverse, which is multiply times 2 on both sides. All right, now the cool thing is this is actually 2 over 1 whole number. These cancel, it becomes a 1. So x is greater than negative 4. Let's see, if I had a negative 5, negative 4, negative 3, negative 2, negative 1, 0. This is going to be an open circle at negative 4, and what we want is everything that is greater than negative 4. You could check it if you wanted to. What if we checked a negative 2? Is negative 2 greater than negative 4? Yes, it is, because it is to the right. How about a negative 5? So we have a negative 5 greater than negative 4. No. Okay, so the solution set, again confirmed, is everything that is to the right. Okay, these are our simple one-step linear inequalities. But what happens if we have a special situation? So this is special situation. Okay, and I'm going to do this multiplying or dividing by a negative. Again, not new, so you should recognize this. The deal here is if you do that, you have to flip the direction of the inequality. So I'm going to just put that little asterisk down here. We have to flip the direction of the inequality. This only applies to multiplication and division. It does not apply to addition or subtraction. And that's the only thing that makes solving inequalities, whether they're one-step, two-step, whatever, it's the only thing that makes them different than equations besides the graphing solution. So let's again pretend that this is an equal sign, and we would do the inverse here to get rid of it. We're going to divide both sides by a negative 9, divide by negative 9, divide by negative 9. And this cancels here, turns into a 1. So y is going to be less than negative 1. Now please note that I changed the direction. We're going to do magic pen. I changed the direction of the inequality. Okay, because I had to divide by a negative. So it was a greater than, now it is a less than. So this is where I changed to the direction. So I'm going to put a little asterisk here. I had to flip it. Let's look at the second one. We're going to, again, and I know it's overkill at this point. Pretend that this is an equal sign. Functionally, I just want you to recognize we do the same thing. This is division, divide by -3. So we are going to do the inverse, and we're going to multiply both sides by -3. At this point, I just want to highlight, okay, I am literally having to ask myself, did I multiply? Oops, I did not mean to do that. So let's erase. Not re-recording because that's a pain in the butt. Whatever, we're going to continue. So I had to multiply both sides by a -3. And if it's negative, that means my inequality is going to flip. I'm just going to rewrite it now because I know it's going to flip. And then I will simplify. These cancel, and I end up with n is less than or equal to a 1 times a -3 is a -3. Let's go back and graph both of these. So this becomes anything less than -1. So if this was a 1, a 0, a -1, a -2, what we want is an open circle here at -1 and everything less than. For this second one, we want everything less than or equal to -3. So if this were a -5, oh, let's change that. A -2, -3, -4, -5. We want a closed circle at -3, and we want everything less than. Okay, and you could check it the same way. If I wanted to check -4, I would say -4, is that less than or equal to -3? Yes, it is. Okay, but -2 does not work. So if we checked -2, this would look like this. -2 is less than or equal to -3? No. Okay, it is not. So solution set is infinite. Many solutions satisfy the inequality. And again, remember this rule. If you are multiplying or dividing by a negative, then you have to flip the direction of the inequality. At this point, we're going to practice using My Open Math in Canvas. So please go to Canvas.